A Williamson ether synthesis is a way you could convert an alcohol into an ether. To begin this reaction, you need a strong enough base that will deprotonate the alcohol that you are using. In this case, if it's a general alcohol, you will need sodium hydride to deprotonate it. Sodium hydroxide is not strong enough to perform this reaction. After that, the second step, you will need a alkyl halide. The type of alkyl halide you will need is a primary or methyl alkyl halide. Okay. Secondary and tertiary alkyl halides do not work. The reason they don't work is because this is an SN2-like mechanism. And so we need to follow these SN2 rules that says that primary and methyl will do SN2, secondary and tertiary will not do SN2. Let's take a look at what the mechanism looks like. To begin with, we take our hydride and we deprotonate our alcohol. Now that we have deprotonated the alcohol, we have O-, and we get some H2 gas. That is the first step of the mechanism. The second step of the mechanism is to introduce the alkyl halide. I will start off by just doing a methyl iodide. Okay, what we're going to see is the O- will perform the backside attack of this carbon that has the halide attached. The halide will get kicked off all in one step, hence why it's SN2-like. And now we will form our ether, and we kicked off our good leaving group. This is what a Williamson ether synthesis mechanism looks like for alcohols. Things are slightly different when we use phenol. Phenol is much more acidic than a typical alcohol, and I have discussed why in previous videos and also in the notes. Because it is much more acidic, we are able to use sodium hydroxide to deprotonate it. Make sure when you are dealing with a phenol in a Williamson ether synthesis that you are using sodium hydroxide and not sodium hydride. Let's take a look at the mechanism. To begin with, OH- will deprotonate the phenol. This will give us an O- on our phenol conjugate base. And now, in this step, we will introduce the alkyl halide. This alkyl halide is a primary alkyl halide. And so again, we are going to see the backside attack and the leaving group being kicked off all in one step. And we will form our new ether. And these are the mechanisms for Williamson ether synthesis with a normal alcohol and a phenol.